Hi guys, this is Yashasya. I'm a student from Sri Venkateswara College of Engineering, currently pursuing Computer Science, Engineering, Artificial Intelligence at third year. So I'm here to present you a presentation on Introduction to the Bayesian Belief Networks. So now let us go. What is the definition of a Bayesian belief network? The Bayesian belief networks are the powerful tool for modeling uncertain probabilistic relationships between the variables. They use direct acyclic graphs and unconditional probability tables to represent and reason about the real-world phenomena. Now, the fundamentals of a Bayesian probability. A Bayesian probability is the foundation of the Bayesian belief networks. It allows us to update our beliefs about the variables based on the new evidence using Bayes' theorem. This provides an principled way to reason under uncertainty. As the fundamentals of Bayesian probability are, a Bayesian probability is the foundation of the Bayesian belief networks. It allows us to update our beliefs about variables based on new evidence. Using Bayes' theorem, this provides a principled way to reason about uncertainty. Now let us go to the directed acyclic graphs (DAGs) in the BBNs, the Bayesian belief networks. So mainly classified into three types: the nodes, edges, and acyclic. When you go to the nodes represent random variables in the domain, and edges indicate direct probabilistic dependencies between the variables. Acyclic, there is no feedback loops in the graph structure. So these are the directed acyclic graph terms which have been used in the Bayesian belief networks: nodes, edges, and the acyclic. Now the CPTs, the conditional probability tables. It has been clearly explained. Conditional probability tables. It is being defined and explained in three types: quantifying relationships, a compact representation, and flexibility. When you go to the quantifying relationships, the GPTs numerically describe the conditional probabilities between a node and its parents in the graph. A compact representation, CPTs efficiently encode the full joint probability distribution over all variables. Now comes the flexibility. CPTs can model complex nonlinear relationships between the variables. So these are the three terms. They are quantifying relationships, compact representation, and the flexibility. This has been ensured in the conditional probability table (CPTs). Now the inference in the Bayesian belief networks. This can be explained by three formats. The first one is observation, propagation, and the inference. Okay, let us go to the observation. Evidence about the state of some variables is provided in the observation, means the information of some variables has been provided in the observation. Now comes the propagation, where the probabilities are updated to the network using the efficient algorithms. After that, now come to the inference. In the inference, the updated beliefs about the unobserved variables are computed. Let us go once again. The inference in the Bayesian belief networks is explained by the observation, propagation, and the inference. Now let us go to the parameter learning in the Bayesian belief network. It means as how the parameter are being learned by the Bayesian belief network model. It is being done by usually three formats: the maximum likelihood, Bayesian learning, expectation maximization. First, in the maximum likelihood, estimated CPT parameters to maximize the likelihood of the observed data. The Bayesian learning incorporate prior knowledge by modeling CPT parameters as random variables. In the expectation maximization, iteratively refined parameter when the data has been missing. That is again, let's go once again. The maximum likelihood, Bayesian learning, and the expectation maximization. The structure of learning in the Bayesian belief networks. So this can be done by usually three formats. They are score based, constraint based, hybrid. In the score based, search for the graph structure that maximizes a score function like Bayesian information criterion. In the constraint based, infer graph structure from conditional independence test on the data. Hybrid combines store-based, constraint-based data together to leverage their strengths. Store-based, constraint-based, and the hybrid-based are the essential in structure learning in the Bayesian belief networks. Now, the applications of the Bayesian belief networks. So it means define that where can the Bayesian belief networks can be applied in the real world scenarios. It can be done by the medical diagnosis, the risk assessments, recommendation systems, and the robotics and AI. Where in the medical diagnosis it can be used in order for diagnosis of data by a complex relationship between the symptom, diseases, and test result. The risk assessment excel at quantifying and reasoning about the risk in the domains like finance or security. Now the recommendation systems, where the Bayesian belief networks can capture user preferences and provide a personalized product recommendations. Similarly, used in the electronic shopping centers such as Amazon and Flipkart. And the robotics and AI, the BBNs, the Bayesian belief networks are used for planning, perception, and decision making in autonomous systems. Last one's advantages and the limitations of BBA of the Bayesian belief networks. The advantages is ability to handle uncertainty and incomplete information. Limitations, complexity of structure and parameter learning. So these are the advantages and limitations of Bayesian belief network. So thank you for providing a valuable time. I think a small amount of information might have been entered to you. So thank you for providing a valuable time. Signing off, Ashasya.